Alright, in the last video we talked about some different types of physical changes, and we said that a physical change does not change the substance, and oftentimes it can be reversed. I gave examples of a paper being colored, and the paper colored green with a crayon, but it's still paper, or we tear the paper in half, but the two different pieces are still paper. If we take the paper and we crumble it up into a ball and throw it across the room, it's still, the substance is still paper. We haven't changed the material. I gave you a rundown of the states of matter, and that when H2O is frozen into ice, or in a liquid form as in water, or boiled out and becomes a water vapor in the form of a gas, all of these different states of matter are still forms of H2O, and its composition hasn't changed. It's just in a different state of matter. Also, if you dissolve something, if salt is dissolved in a liquid, the salt is still salt. It's just ionized and it becomes dissolved in the water, but the salt is still salt. It hasn't really changed its composition. Now, chemical changes are the opposite of that, or I shouldn't say the opposite. They're very different. Chemical changes happen when the substance changes into another different substance. There's a chemical change. So in other words, let me give you an example. Let's say we're baking a cake, and we take milk and we take eggs and flour, sugar. I don't know how to bake, so I'm not sure. And we make a little cake, right? We make a cake and we use the eggs and the milk and the flour and the sugar and the butter and whatever else you use to make a cake. And you make a little birthday cake, right? Well, these are supposed to be candles. All right, so you make this little birthday cake, and so you've gone through a chemical change. That egg is no longer an egg. That the milk is no longer milk. It's all incorporated into this cake, and it went through a chemical change. All right. Another example is, let's say if you have, let's see, a carton of milk. Let's see, I don't know how I'm going to draw this. Oh, that's not bad. Okay, let's say we have a carton of milk, and we'll label it milk. Let's say we have a carton of milk, and then after 2 or 3 weeks, maybe a month, and you go into the refrigerator and you open up that milk and you take a taste, and then you just really doesn't taste very good, right? You taste it and it's very sour. Well, that milk has gone through a chemical change too, and it's no longer the milk that you knew. It's curdled and it becomes something other than milk. It's spoiled. Another example would be possibly metal rusting, and I won't be able to draw anything, so I'm just going to write rusting. All right, that it rusts, or when something is set on fire, when it's combusted and it's set on fire, then it changes into something else completely. It changes into different types of, it changes into an ash and it becomes burnt. So chemical changes are when a substance goes through a reaction and it changes into something completely different. And as we said when we talked about physical changes where it can be reversed, chemical changes, let me change colors. Chemical changes cannot, whoops, let's do this, generally cannot be reversed. All right, so another example of this, just to give you an idea of the chemistry behind it, this is the formula for bicarbonate of soda and sodium bicarbonate and vinegar. All right, so this is the solid. Oops, sorry. Let's see. This S means that that's the solid and this is the liquid. And so this is the baking soda, and this is the vinegar. All right, and then what we get is a CO2 gas, and then as products, this is like we combine it, and then this arrow shows that what it yields or what it produces. So when we combine baking soda and vinegar, and I'm sure you've done it in elementary school, what you end up with is different products, and one of the products is carbon dioxide. Another product is water. Okay, another product is sodium in a liquid form, aqueous, and then here this is let me think, what is that? That is, oh, that's right, this is a form of the sodium acetate, and it's just hard to explain. But anyway, this combination of just this simple powder and this simple liquid will end up in creating, you know, four different types of substances. So we get carbon dioxide gas, we get water, we get a sodium mixture in water, and an acetate. This is a good example of a chemical change where this baking soda is no longer baking soda anymore. This vinegar is no longer vinegar anymore. And all of these letters represent different elements. And they break up and then they recombine to form, let's see, 1, 2, 3, 4 different products. And they create 4 different products and 4 completely different substances. And it's not like it's very easy to change back. It's kind of a one direction reaction, and you end up with different substances. And so the vinegar is no longer vinegar, the baking soda is no longer baking soda, and we get different products. So that is an example of a chemical change. All right. So again, chemical changes, substances changes into another substance. You know, baking a cake, when milk sours, when you have a piece of fruit, an apple or banana, and it decays and it rots away. When metal rusts, or when you burn something. Those are all examples of chemical changes. And it changes, but you really can't change it back. All right. I hope that's kind of clear. It's getting to be long. If you have any questions, ask in class.